So we're going to look at the difference between linear equations and exponential equations, and then we're going to do some more solving of those exponentials and logarithmic equations. This is section 8.7. Let's get started. All right, let's look at this real quick. Back in the day, Algebra 1 and at the beginning of the school year, we graphed lines. They were in the form, this was y, this is like a y, f of x equals mx plus b. We got m as a slope and b as our y-intercept. Are you with me so far?
Yes, ma'am.
Just this chapter, we have been studying exponentials, where we have a function equals some a value where we start, and we're going to multiply an exponential. We already, this looks familiar, right? Okay. Mm-hmm. So let's go back to this linear equation. This linear equation says this. It says that we're going to start at some b value. And that's how we always graphed it. We started at the b value at the beginning, right? We started at that b value, and then we stepped up the same.
The b is the intercept.
That's the y-intercept. And then we went up the slope. We went up and over the same amount each time. We went, if it was 1/2, we went up 1 and over 2, up 1 and over 2, up 1 and over 2, up 1 and over 2 every single time, correct? Okay. An exponential starts at that a value. Remember, the a value was our y-intercept. Did we go up the same amount every time? No, we went out and up maybe a certain, like 2 and then 4 and then 6 and then 8, or we went up, actually not even 2, 4, 6, 8. We went up 2 and then 4 and then 8, then 16, then 32. It doubled every time. These go up. This one adds something every time. This one multiplies something every time. Are you with me? Let's do numbers 1 and 3. These are multiple choice. You need to just, and yours on your paper actually show the multiple choice. You need to decide whether the word problem represents a linear or an exponential. Remember, linear adds something every time. Exponential multiplies something every time.
So this is linear because it's adding.
The library books, the library has 8,000 books and it adds 500 more every year. Is that linear or exponential?
That's linear.
Linear.
He said
All right.
ads every year. I was like,
Yeah, that's the key word. It adds 500 every year. Number 3, are you ready? The same instructions decide whether the word problem represents linear or exponential. A bank account starts with $10. Every month, the amount of money in the account is tripled.
exponential.
It's
Definitely
linear.
exponential.
Why is it exponential?
Because it's tripled. When you say tripled, that implies multiplied by 3.
Okay.
Okay, so it multiplies it. All right, the next part of this, by the way, we've finished half of the lesson. Well, at least half of the explanation. Maybe not half of the problems together. We're going to bring it all together now. We're going to do some more solving of those equations. We did logs and exponentials last time. Now we're going to keep going. We're going to use the definition of a log to do our solving, and we're also going to use all these properties of logs to solve. Are you guys with me?
Yeah.
Here we go. Doing number 6 and 7. 6 and 8. Last week we did odds. Today we're going to do evens. This left side we can condense down into one log. If I'm adding, what do I do with the x plus 4 and the 8? We multiply them, because that was our property of log. So that says log, I'm going to put the 8 in front of the x plus 4. That still equals 3. Are you with me so far? All right. Now we're going to use that definition of a log. What base is down here if there's nothing?
10.
It's a 10. And so what to the what equals what?
Log 10 cubed yeah.
10 to the third equals.
8 open parentheses x plus 4.
Are you with me? Make sure you got that. We always do that base to the outside equals the inside.
So
Now this has no logs. This is an equation you might have seen in Algebra 1, except maybe
Yeah.
not 10 to the third. But what's 10 to the third?
300?
Nope.
No.
1,000.
1,000. So we got 1,000.
Zeros.
I'm going to now distribute the 8x.
It's 1,000.
So 8x plus 32.
Yes.
Oh, I didn't put an extra
Why'd
zero.
you- Oh, okay, good.
Thank you. Thank you. We're going to move the 32 over by subtracting. What's 1,000 minus 32?
900.
68.
Please make sure that she's right.
968.
Okay, now we're going to divide by 8. X will equal
21.
121.
I'm so glad that was even.
Me too.
All right, let's go to number 8. On the left-hand side, we can bring together and make this into one log or one ln. This will be ln what?
ln 2 to the x minus 9. And then you put an open parenthesis.
2 times x minus 9. Yes, I agree. Equals ln 58. This time, this is a little different than the first one. The first one, we didn't have an ln on both sides or a log on both sides. We had just a number. Now we have an ln on both sides.
Can they cancel?
Yeah, you can cancel.
So the
that out.
ln's, in a sense, cancel, and we'll be just left with 2x minus 9 equals 58.
And now we can do.
Just solve it like algebra, okay? Nothing. So I'm going to move that 18 over. I'm going to add it to the other side. What is 58 plus 18? Can someone help me?
76.
Yeah, 76. So then I divided both by 2 and I got x equals 38.
That's what I got as well.
Do number 10.
Yep.
Yes, please.
So just cancel it out and you get log 8 to the 7x plus times x plus 8.
Yeah, so we're going to bring together the 7 and the x plus 8. So we'll have log 8, 7x plus 8 equals log 8. All right, so the logs, in a sense, cancel themselves out, and we're just going to have 7x. Can I distribute the 7x plus 8 now?
Yes.
Don't we just divide? No, do
17.
we have to divide both sides by 7 first?
Ooh, you could actually.
17 over
If
7.
you wanted to do it that way, Natalie, I like that.
No, 73 can't divide by 7.
Oh, it can't.
Yeah,
Oh, so then let's
it's x equals 17 over 7.
All right, so we'll do 7x plus 56 equals 78. Subtract the 56 over, and what do we get?
17. Gross.
7x equals 17.
Over 7. X equals 17 over 7.
And it doesn't tell us to do decimals, so do you want us to leave this in fraction?
Yes. Number
She wakes me
12.
up.
Are you ready? This time we have a subtract in here. We don't have an add. How does that affect everything?
Fraction.
It's a fraction. So we're going to have ln x over x minus 3 equals ln 59. Now what do we do?
X equals...
Well, yeah, the ln's are going to cancel, right?
Yeah.
So we're going to have... This one might be a little tricky on how to solve it. I'm going to come up here.
So do we multiply it by?
So it would be 59 over... Oh, X equals 59 over parentheses X
do we
minus
not multiply
3.
both sides by x minus?
That's exactly what we're going to do, and I think that's what she's trying to say
Yes.
too. We're going to bring this up to here. Yes. We're going to move the x minus 3 up to multiply to the 59. So we'll have
No, you in the trash. What you doing?
x equals 59 times x minus 3.
Oh goodness. Oh, Dee you scared me.
X equals 59x
Knock it out. Come here.
minus, what's 59 times 3?
177.
177. So I'm going to bring the 59 over there.
So that's going to be a negative...
You'll have a negative on both
60.
sides, right? Or you can have a positive on both sides. What is it? Negative
60?
58.
You're right. Thank you.
X equals negative 177, right? Divide by negative 58. Does it go in evenly?
Nope.
No way.
Does it reduce?
Nope.
So 177 over 58. Is that true?
Yucky. Do we cancel?
All right. 177 over 58. Let's do another one. 14. Let's go here. How can I condense the left side?
Exit the ln's out.
Yes. Well, not yet, because there's not an ln on the other
Divide
side.
everything by 2.
No. How can I condense them? Bring them together.
Oh,
Can
you
you-
just put ln 8 times 2x
Yes.
squared.
So I'll have ln. Can I make the 8 and the 2 be a 16?
Yeah.
Yeah.
Okay. Equals 2. This time I don't have an ln to cancel on both sides, so what do I do?
Gross.
What is the base on ln's?
10.
10.
No?
Oh, E.
E. So what to the what equals what?
718.
What?
ln to the 2 equals e? Or is it ln?
Oh, E to the 2 equals 16x squared.
All right. e to the 2 equals 16x squared. We no longer have any ln's, so that's great. What do I do now?
Divide both sides.
Divide both-
Yes,
Yeah.
divide both sides by
2.
Square root.
16.
Square both. Take the square root.
Yeah.
of
Not
you
yet,
gotta
not till we get
square
x squared by itself. So I'll have x squared equals e squared over 16, correct?
Yeah, and then I can take the square root of both sides.
Now we can take the square root of both sides.
And you just get x equals 16.
Careful.
E over 4.
We'll have x equals e over 4. Be careful. We took the square root of both sides. What do we have to do?
Plus or minus.
Plus or minus.
So are we solving that then?
We're done.
Putting that into our calculator? Oh, okay.
Nope, we're done. All right, let's do number 16. Number 16, how can I condense this to be 1 log?
Can you just put the 3 outside of the parentheses? So log 2, 3 open parentheses 3x minus 9.
If it was an add, we could,
it's
but this is a
negative.
subtract. So how do we do
divide by
that?
3.
So we divide it by the
So
3.
can it just be x minus 3?
We're going to have log
2.
base 2,
X
3x minus 3 over 3. Yeah, we could.
It's
Actually, that's a
x minus
9.
So can I just skip that step and write log 2 x minus 3?
You want to make this be
X minus 2.
x minus 3.
3. Thank you. Yes, log 2 x minus 3 equals 4.
How did we go from
Am I allowed to just skip
Yes.
the step?
Awesome.
how did we go from step A to step B?
Dividing everything by 3.
Yes, there was a 3 on the bottom, so I can reduce both of those by a 3. Does our logs cancel out on this one?
No, but we can do 2 to the 4 equals x
Yes.
minus 3.
So this over here, this is 2 to the 4. 2 to the 4th power equals x minus 3, correct?
Yup, that's true.
What is 2 to the 4th power?
16.
Yeah.
Yep.
16.
So we have 16 equals x minus 3.
19 equals x.
Yes.
X equals 19.
You don't mind if I put 19 equals x?
I don't mind. I, for some reason, like my x on the left side. I don't know. But you can put it on
I
the
kind
right.
of just keep it all like.
On the same side.
I've
I
not
agree.
noticed I've not noticed a pattern. I think it's just wherever it ends up. I'm like, yeah, we're done.
Yeah, whatever. Yeah. All right.
That's it.
Yep. This is what we learned. You learned how to tell the difference between a linear problem and an exponential problem. And you learned how to solve exponential or logarithmic equations that have logs in them now. Okay?
Cool.
All right. I hope this has been helpful.